Hi, welcome to Nandi Tech Bytes. In this video, we are diving into a critical topic for DevOps engineers. The topic is networking. If you are managing applications in the cloud or working with on-premises servers, or you aspire to be a cloud and DevOps engineer, then understanding networking is essential for deploying reliable and high-performance applications. This is the first video of the series, and in upcoming video, we will deep dive into AWS networking. So please subscribe to the channel now if you have not already and stay connected for upcoming videos. Why networking matters for DevOps engineers. Imagine if your application crashed because its services couldn't communicate, or if users faced frustrating delays due to poor network setup. These are common issues when networking is overlooked in DevOps. In this video, we will break down the key networking concepts that every DevOps engineer needs to know to prevent these problems. What is a network? At its core, a network is a collection of connected devices, computers, servers, routers, switches that share data and resources. Routers help direct data between networks, while switches connect devices within the same network, managing traffic to keep everything running smoothly. Here we are talking about IP addresses, subnets, and protocols like TCP and UDP. Without these basics, setting up efficient, reliable connections between servers, applications, and databases wouldn't be possible. For example, IP addresses uniquely identify each device on a network so they can find each other, while protocols like TCP and UDP defines how data moves reliably or quickly. Going forward, we will learn more about these IP, subnets, and protocols. The OSI and TCP/IP models are frameworks that helps us understand how data travels across a network, layer by layer. For example, when a user accesses an application, the request goes through multiple layers to get from their device to the server and back. In the OSI model, there are 7 layers, starting from the physical layer where raw data is transferred over cables up to the application layer, where user interactions happen. The TCP/IP model is more simplified and widely used, focusing directly on real-world internet traffic. As a DevOps engineer, understand these layers is vital because they reveal where issues might be happening and guide us in configuring systems to perform efficiently. Let's understand IP addresses. IP addresses are like addresses for devices on a network. They are crucial because without IPs, devices wouldn't know where to send data. IPv4 and IPv6 are two types. IPv4 is the older format using 32 bits and divided into classes A, B, C based on network size. Class A, for example, is for very large networks, while Class C is for smaller ones. As we ran out of IPv4 addresses, IPv6 was introduced, providing for more unique addresses to accommodate the growth of the internet. Let's talk about subnets and how they help organize a network. A subnet is a smaller network within a larger network. By dividing a network into subnets, organizations can improve performance security. For example, consider a company network with an IP range of 192.168.0.0/16. The /16 prefix means that the first 16 bits are used for the network portion, and the remaining bits are used for the host addresses. So the network portion of the IP address is 192.168, and the host portion ranges from 0.0 to 255.255. This gives us a total of 65,536 IP addresses. Now let's break this larger network into smaller subnets for different departments within the company. These subnets are divided using a /24 subnet mask, which allows for 254 usable IP addresses in each subnet. Each /24 subnet is broken down like this. The subnet mask is 255.255.255.0, which in binary is 8 times 1 dot 8 times 1 dot 8 times 1 dot 8 times zeros. With 8 bits left for host, this gives us a total of 256 IP addresses per subnet. However, the first address is reserved for the network address
and the last address is reserved for the broadcast address, leaving us with 254 usable IP addresses. By splitting the company's network into these smaller subnets, each department, HR, finance, and IT, has its own isolated network. This separation improves security, reduces network congestion, and helps with better network management. It's good to know the basics, but it doesn't mean you have to calculate it manually in real time. You can always use online IP subnet calculators for doing this. Firewalls are critical in network security. They control and filter the flow of data, only allowing in the traffic we have defined as safe. Imagine a firewall as a security guard. It inspects every packet of data to ensure it's safe to enter or leave the network. Without firewalls, our systems would be open to all kinds of attacks like unauthorized access, malware, and data leaks. In a DevOps role, configuring firewalls means we can define specific rules for each subnet or application, ensuring that sensitive data remains secure and only approved communication happens.
Components of a network and types of network. There are mainly two main types of networks: local area network or LAN, which connects devices within a confined area like an office or home, and wide area network or WAN, which spans larger geographical regions connecting cities or even countries. These types are the foundation of any network structure. Cloud networking uses cloud-based resources to create, manage, and expand networks without physical limitations. Unlike traditional setups, cloud networks are virtual and highly scalable. For example, AWS offers virtual private clouds, while Azure and GCP offer similar virtual networking services. Importance of networking for DevOps. Networking is a crucial in DevOps for several reasons. First, application connectivity is essential. Microservices like payment and authentication need to communicate seamlessly. Network security also matters, with firewalls and security groups protecting sensitive data. Deployment and scalability require load balancers and subnets to manage demand, and troubleshooting network issues is vital for maintaining uptime and performance. Networking in DevOps workflows. Networking is deeply embedded in DevOps workflows. For instance, Kubernetes networking enables service discovery and load balancing, helping pods communicate inside or outside the cluster. Cloud services like AWS VPC or Azure Virtual Network allow DevOps engineers to manage resources securely and efficiently. Let's recap the essentials. A network is a collection of devices that share data and resources, and as a DevOps engineer, networking knowledge is key to secure and efficient application deployment, scaling, and troubleshooting. In our next video, we will deep dive into AWS networking basics and show you how to create your first virtual private cloud or VPC. So don't miss it. Thank you for watching. Don't forget to subscribe to Nandi Tech Bytes for more upcoming DevOps insights. See you in the next video.